there's a sophisticated set of management capabilities in these products. 11 switches, a combination of PoE and non-PoE, gigabit and 10 gigabit switches with 802.3 AT support, so that's 25 watts per port available. So let's go through and have a bit of a look. So 11 new switches, 5 a gigabit with various port densities, and that's the AMS range, so alloy managed switches. The next 5 are exactly the same feature set, but they're PoE, and as I said, that's 802.3 AT or 25.5 watts per port, and obviously backwards compatible with the old 802.3 AF. And then we have the 11th switch in the series, which is an SFP based switch for high density fiber environments, and as I said, all of these boxes are layer 2 and layer 2 and 4, but no routing capabilities. So the part numbers, so we understand what we're talking at. Anything starting with AMS is an alloy managed switch and does not have PoE capabilities. Anything starting with APS is an alloy PoE switch, and these are also managed. So the same feature sets across both of these, both halves of the range. Just the only differentiator there is that the APS support full 25 watts PoE. The next series in the part number indicates the number of twisted pair ports available. The next series after that indicates the number of SFP ports, and if there's a third series, what we see is the second series gets condensed, and the third series of numbers indicates the number of SFP plus or 10 gig capable ports. So all pretty straightforward, pretty easy to read. So in terms of the actual feature sets and things that we're looking at, or the port densities, so the first guy in the range is the XXX, so there's an AMS and an APS version of this switch. 10T to SFP, so 10 port managed gigabit switch with 8 10100 1000 ports and 2 paired SFP ports. Next one is a 24 port version of that, so we actually have 26 ports on this switch made up of a combination of SFP, SFP plus. The next one is a 48 port switch with 44 by 10 100 1000 and 4 pairs of SFP, and then the next two are the 24 port and 48 port, but now we have 10 gig uplinks via the SFP plus ports, and plenty of port density on the SFP plus there as well for port trunking and things. And finally the SFP based switch, which is the AMS 4T 24S 4 SFP, so it's 28 ports of managed gigabit with 20 SFP ports, 4 paired SFP and 4 SFP plus. So in those high density fiber environments, this is a really nice switch, and in fact it supports a couple of things that the other switches don't, and I'll get to that a bit later. On the PoE side of things, all the APS switches are 802.3.AF and 802.3.AT. You can see there the wattage that's available on each of those switches. A bit later I'll go through how that breaks out and what it means to us. But the 10 port switch, 130 watts available for PoE, 24 has 250 watts, and the 48 ports have 360 or 380 watts of power available for PoE. And the Layer 2 feature set, as I said, these guys are very sophisticated boxes, and at the price point I'm really impressed what Scott and the team have managed to squeeze into these guys. On the spanning tree side of it, we've got all flavours of spanning tree, so spanning tree, rapid spanning tree, and multi-spanning tree for in VLAN spanning tree, LAC-P for our port aggregation and port trunking. VLAN support, we've got leading edge VLAN support. Any sort of VLAN you can think of, they're supported in these boxes, but obviously 802.1q is the one that most people are interested in. GVRP, so The GBRP VLAN registration protocol, this is a really handy one in large environments. I'll talk more later about what that does, but again, in really large networks, this is a nice one to have at your fingertips and saves you a lot of configuration issues. DHCP relay, again, a nice feature to have in multi-site environments where you've got a centralized DHCP server. Having DHCP relay available in your switch infrastructure gives you a really simple centralized way to manage your DHCP protocols. And all multicast support, so we have IGMP and MLD support for multicast and reducing the amount of multicast traffic on our networks in layer 2 for both IPv4 and IPv6. And again, we'll talk more about them a bit later. Quality of service. I've said to guys before, when it comes to hardware queues, the more the merrier. We do 8 hardware queues across all these switches. You'll see how that maps out to quality of service later when I start talking about the quality of service capabilities in detail. But as I said, 8 hardware queues, really important in a multimedia environment, and let's face it, what environment isn't these days? Scheduling, we support strict priority and weighted round robin. We'll talk about them later as well. Classification, again, the ability to do classification and reprioritize traffic and honor the priority of the traffic, and having multiple ways to react and respond to the priority of traffic and to reclassify traffic is really important in a multimedia environment these days. And again, these switches are bleeding edge with the number of ways that we can tackle that traffic prioritization and classification. And we also support rate limiting. Rate limiting is important in service provider networks, potentially in shared office environments and multi-tenant environments and gated communities and nursing homes, and all sorts of different customer bases have, or different customer segments have, a requirement for rate limiting. These guys support it on every port, support it inbound and outbound, and can be done per VLAN, per port, or even per flow, and a flow being traffic between any 2 destinations or any 2 devices. So I've said really granular access to that as well. LLDP, I'll go into that later, but that's open standards discovery protocol that lets us do some clever things with telephone handsets in particular. On the security side, we have these switches have everything in them that you'd need from a security point of view in a layer 2 switch. So we have secure shell for secure configuration via command line. We have SSL for secure configuration via browser. 802.1x for network access to require users to authenticate to the network before we even allow them on it. This is used also in a lot of systems now in conjunction with LLDP to not only allow people onto a system but also to do some level of dynamic configuration. Private VLAN Edge is a very secure low-level VLAN that I'll talk a bit more later in the VLAN area. Port-based security and IP source guards gives us some mechanisms, one more flexible than the other, but a mechanism to lock down what devices can be attached to a specific port, and then to protect against IP address spoofing as well on that port. So again, in customers that require high levels of security for their physical network, these are all protocols and feature sets that they're looking for and asking for, and as I say, in this range of switches we support them. Radius and TAC hacks, obviously, to enforce authentication on people having access to the switches for configuration, etc., etc. Access control lists, we do everything that everybody else does and just as well, and storm control for broadcast and multicast storm suppression at a per port level. So again, very granular, sophisticated level of broadcast control and denial of service protection. On the management side, as we've said before, HTTP and command line, HTTPS and SSH for securing those. We also support dual firmware, and this gives us the ability to, when we upgrade firmware across a network, particularly a larger environment, we have the option to roll that back if we need to for any reason. SNMP, all flavors from old SNMP1, the original one, up to SNMP with the secure passwords. So that's well catered for there. And ARMON. We'll talk a bit more about ARMON later and what I like about that. But SNMP and ARMON in medium to large networks is a must for helping you debug problems, particularly voice and video over IP nowadays. Having a historical view of what's going on a network with ARMON and alerts via SNMP is an incredibly important feature set. Both IP4 and V6, as I've already alluded to, port mirroring and SFlow. SFlow is a great traffic accounting protocol that's hardware based and therefore is a lossless technology for traffic accounting as distinct from NetFlow, which is, I like to call it best guess, but it's a sampling based accounting protocol. So it assumes that if you did this much work in the last 10 seconds, you'll do that much in the next 10 seconds. Sort of approach. As I said, SFlow as an accounting protocol is hardware based and therefore wire speed. And green Ethernet. All of us are seeing more and more the importance of green in our tender responses and our sales pitches. So of course we're supporting it on this this range. So link detection. Great little one. Turns off power for disconnected and idle clients and re-establishes connectivity when something is connected or goes out of an idle state with zero packet loss. And that's a great one. And the next one is cable length detection. So this automatically adjusts signal strength based on cable length. So this will save you money on every single port where the cable run isn't to the maximum of the Ethernet spec. So great inbuilt savings right there. The extra features supported on the fiber switch that I mentioned earlier, they're all about carrier protocols. So these are protocols that the carrier and service provider network architects will be looking for, and they're all around this OAM, or the concept of operation, administration and management. So 802.3AH, 802.1AG and the IEEE and ITUT standards listed below are all things that the service provider and carrier market are looking for in their layer 2 boxes, and of course we're supporting them. Here's a range of the GBICs that you might want access to, or the SFPs you might want access to on these boxes. You see at the top of the screen the SFP Plus, down below that the SFP. So SFP Plus are the 10 gig interfaces, the SFP are the 1 gig interfaces, and there's also SFP 100 megabit interfaces. So one of the special things about the SFP and SFP Plus ports in these switches is all of the SFP ports can either take a 100 meg fiber interface or they can take a gigabit fiber interface. The SFP Plus ports can take an SFP Plus 10 gig interface or an SFP gigabit interface. So each of those modular ports, SFP and SFP Plus, in this entire range of switches are capable of dual speeds. It makes them very flexible in a lot of environments. And I know there's still a hell of a lot of high density 100 meg fiber infrastructure out there that people want to leave at 100 meg because of the devices hanging off the end of it. So as I said, very, very flexible range of switches with these flexi dual speed capable SFP slots. So It was reasonably quick. That's the sales summary, guys. 11 new switches, 5 configurations times 2, PoE and non-PoE, plus a high-density fiber switch. Features, IP4, IP6, PoE, 802.3 AT, and as I said, very sophisticated management capabilities across the entire range. And QoS, I believe it's best of breed. VLAN, certainly best of breed. Security, everything you need in a large network, a large layer 2 network, and green power, of course. So, as I said way back on the first slide, with a sophisticated list of layer 2 for QoS, security features, and AT PoE support, this range of switches is a pretty good solution set at the edge or even the aggregation layer for small, medium and large networks. So guys, if you can't find a market for these guys at the price point that Scott and the team have put them out there at, I'll be extremely surprised. Now, with that, I'm going to move in and have a closer look at some of these technical features, and we'll try and move through this fairly quickly. So let's get into it. So first of all, the PoE, as we said, these are all AT capable, so 25.5 watts per port. So in PoE, there's 4 classes of devices recognised under both the AF and the AT standard, and the classes are broken up based on how much power that device in that class requires or what range of power it'll request from the switch. And class 4 represents our AT devices, and typical devices that require that sort of power above and beyond the 802.3 AF, typical devices that will require more power, and the AT PoE support, pan, tilt, zoom PoE cameras. And one of the ones that I dragged off the internet, the first one I could find, the Access PTZ Zoom PTZ camera, class 4 with a maximum draw of 14.5 watts. So you can see even though it's an AT device, it's only just gotten up over that class 3 or the old standard. And we note that's the maximum draw. I couldn't get an average draw for that particular device, but if we go down and have a look at one of our more power-sucking phones that we sell, the Snom 821 with a full colour voice over IP handset with gigabit ports and lots of buttons and things on it, that guy has a maximum draw of 10 watts, but its average power draw is 2.4. So down here on the chart at the bottom, what we're looking at there is we're looking at each of the switches, what the available watts are for PoE, and how many class 1 devices, how many of each class devices they can support. So if it's got an A in that spot, that means that it can support class 1, for example, the first switch, class 1 devices on all ports, the class 2 devices on all ports, class 3 devices on all ports, or class 4 devices on 5 ports. But this is assuming maximum draw. This isn't allowing for what the real draw is likely to be, such as 14.5 rather than 25.5, and doesn't also allow for what the actual average draw is that we're going to see on devices connected to it. So the takeaway I want you to have from this slide is understand how much you've got available, understand that you can go to up to a maximum of 25.5 per port if you really need that much, but always do budget and power calculations on what you're going to be plugging into a switch, and understand just the capacity that you've got there and how you're going to deploy it. These guys all have some pretty good power management in there and priority failback and all those sort of things if you do overdraw on a box, but as I say, smart design, you don't get into that situation. Spanning tree, as I said earlier, 3 flavors. So traditional spanning tree, and the problem with that it was slow to reconfigure when something changed, and typically meant outages of 1 to 2 minutes for the whole network while it sorted out what it was doing. So then they developed a rapid spanning tree, and that resolved most of those problems by actually planning how it would reconfigure in advance if something failed or became unavailable. And that allowed us to get the reconfiguration time down to milliseconds rather than minutes. And then MSTP allows us to have a spanning tree configuration inside a VLAN. So now we take a spanning tree out of our physical switch environment and bring it down to our virtual switching environment and have spanning tree topology within there. This is typically only used in very large environments, but it's quite often one of those tender questions: do you support it? The answer is yes. As I say, spanning trees come a long way since the early days of Ethernet. LAC-P, or Link Aggregation Protocol. This is obviously the ability to aggregate and join multiple links together between two switches in the network. So we can take, instead of a single gigabit link between two switches, we can use some of our spare ports, add it up 2, 3, 4, whatever, until we get a maximum, so to increase the capacity and give us the ability to do a linear increase in bandwidth rather than a generational increase. So we can go from 1 to 2 gig between switches instead of having to go, if we want more than 1 gig, to buy a switch with a 10 gig connection between it. So as I said, it gives us a linear upgrade path and in-box ability. One of the other things is it also allows us to create a path redundancy and the ability to have, for example, different fiber paths going through different patch infrastructure or cable infrastructure. So if some physical cabling is taken out, we still have a redundant path and the network stays up. Couple of things with setting this up, depending on which version of link aggregation that you use, and we support 803.AD and 802.1AX on these switches. Depending on which way you go, will be how manual that configuration is. If you're using the old AD standard, or if you're connecting to a device that's got the old AD standard only, then you must got to manually configure those ports and make sure that they're both full duplex and set to the same speed. Outside of that, all very auto magic. VLANs, as I said before, we've got every sort of VLAN under the sun, so I'll touch on a couple of them in more detail. But 802.1Q, most common type of VLAN, and of course this enables the use of 802.1P for priorities. As you're all aware, in an 802.1Q VLAN, we add some extra bytes onto the back of the Ethernet packet, and within those bytes on the back of the Ethernet packet is where the 802.1P priority information is kept. So if that's not there, then the 802.1P obviously doesn't work. So then we're looking at some other sort of priority mechanism. Port-based VLANs, these are untagged, so these don't have those extra bytes stuck on the end. Some of port-based VLANs work very well in reasonably small to even up to medium-sized networks, but all usually manually configured. Mac-based VLANs, I don't know anybody that uses Mac-based VLANs anymore. I'm sure you guys out there probably do, but as I say, I don't. And they can tend to have quite a high administrative workload in setting them up and managing them. Management VLAN, this is just the ability to have a VLAN to manage our devices, where that VLAN is separated out from and away from the data traffic on the network, and gives us the ability to ensure that data users can't get to the management interfaces of our switches. Private VLAN and private VLAN edge. These are this allows us to create VLANs within a subnet. It's also very popular in service provider and gated community and multi-tenant facilities, because what this allows us to do is put multiple ports into a VLAN, and they all get pushed to a single exit point, to the internet or wherever, but they can't see each other. And so private VLAN is a more complex version of that, and private VLAN edge is the same idea, but reduced to within a single switch. So a very simplistic version of that, but very handy, as I said, serviced offices and things where you want each office to have access to a single resource, but for none of those offices to share traffic between each other. Q&Q, I'll talk more about that in a minute, and voice LAN, auto configuration of a voice VLAN based on the hardware that's connected to it, and we'll see a little bit more about that in a minute. So as I said before, 802.1q VLANs, Ethernet frame is 4 bytes longer, maximum number of VLANs is 4096 based on the addressing capacity, the address part of those 4 bytes. Frames can be tagged or untagged. So what that means is frames can come in untagged and be tagged when they enter the switch, and then be untagged when they exit the switch, or they can be tagged when they enter the switch and that tag can be on it. So lots of different ways and flexibilities in an 802.1q environment. Again, the 802.1 priority information is inside that tag. The usual configuration so we have the idea of access and user ports, okay, and these usually, how we configure this, and not always, but usually is how we configure this, is they add a tag to the frame when the frame comes into the switch based on certain criteria, and then that tag contains the VLAN ID, and then that packet's transit across the network is based on what VLAN it is, and it can only get in and out of other ports that have the same VLAN ID. Again, it's usual that access user ports only accept untagged frames on input, but not mandatory, and in a lot of cases now in the voice world where a phone is acting as a switch between a PC and a physical switch, we see tagged frames. They're quite common nowadays for tagged frames on ingress. And again, usually but not always, we strip the tags from the frames when we spit them out of the switch to a end device. Hybrid access ports that accept tags and untagged frames are potentially a security risk, and if you're interested in that side of it, have a look at Google VLAN Hopper, and that'll explain to you some of the security risks associated with those hybrid configurations. So as I said, 802.1q VLANs, we have different ports on a switch allocated to different VLAN IDs, and those devices can only see devices with the same VLAN ID, and we have the concept of trunk ports which carry multiple VLANs between switches. And remember, so just in this example, I'll refer back to this later, so that trunk port has configured on that VLAN ID 100 and VLAN ID 200 to allow all of my VLANs to traverse between those switches and be available on both switches. We'll come back to how we can configure that auto-magically later. Private VLAN, I think we already discussed all of these, and I don't need to go back into them again, but as I say, the information's there in the slides if you need to refer back to it. Q&Q VLANs, this is service providers love Q&Q VLAN switches, which means that allows them, instead of investing in very heavily inexpensive overhead MPLS infrastructure, they can use low-cost VLAN infrastructure across their service provider cloud and use Q&Q switches to hide the customer VLANs so they don't clash with the service provider VLANs across the infrastructure. So basically it double tags a packet. So we have the customer VLAN that we're seeing here, the customer VLAN 100 comes into the switch and gets re-tagged with an extra VLAN tag of VLAN 50 on top of it and travels across the service provider network as VLAN 50, and when it gets to the other side and gets pushed out onto the customer Q&Q capable switch, that strips off the VLAN 50 tag, leaving the VLAN 100 tag in place, and that's available to then get it to the right place in the customer network. So as I said, very a sought after feature by service providers. Voice VLANs. Voice VLANs can be dynamically created on ports as the telephones are plugged into them. So how this works is you tell the port to look for an OUI, or the organizational unique identifier. This is the first 6 bytes of the MAC address. So for example, in here I've given you the SNOM one, 0000413. So I configure the switch that when it sees a MAC address of that type, that it'll recognize that it's a voice VLAN, or that's a voice device, and to put it into the voice VLAN. So quite a popular feature now as well, especially in large networks. GVRP. So this is a great one. The full name for this is the Generic Attribute Registration Protocol VLAN Registration Protocol, or GVRP for short. And what this does, remember our trunks, where I said we had our trunk ports, and we'd have to configure that to allow VLAN 100 and 200 to be able to traverse between our 2 switches. What GVRP allows you to do is set up those switches so anytime they see a new VLAN, that they add it to the trunk, and when that VLAN disappears, they remove it from the trunk. And so we can dynamically configure those trunk ports and add new VLANs into our environment without having to worry about going back and configuring all our trunks to have them on there as well. So again, big time saver in large environments. DHCP relay. This is great for organizations that are trying to do DHCP from a central point across an organization, and that gives us the ability. So because DHCP is a broadcast protocol, so DHCP doesn't go across a routed network. So when my DHCP server, such as in this slide here, is on the right, it's connected into the network 2 switch or switching infrastructure. DHCP packets can't get to it from across the other side of router 1 over there on network 1. So with DHCP relay, that gives us the ability to tell our switch network where the DHCP server lives, and we can forward those DHCP requests across the router to the DHCP server, and the switch can respond on behalf of the DHCP server and forward the packets out to the actual client. So as I said, this is an easy way to have a centralized DHCP server infrastructure across routed networks and multi-sited infrastructure. Now, snooping, query, or proxy. So IGMP operates between multicast routers and video clients, or usually video clients, but any multicast clients. So in a multicast environment, by default, if you're not supporting IGMP protocols, by default, the multicast is actually broadcast. So we're sending it out to everybody on the network. With IGMP snooping, what we have the ability to do is make sure that it is only sent out to the clients that require it and those who have requested to be part of that multicast group. Obviously, this cuts down the broadcast traffic going across all of our network and multiple interfaces, etc., etc. So IGMP, very good thing, pretty much mandatory in this day and age. MLD is just the IPv6 version of IGMP, and in fact IGMP v2 and v3 have a direct correlation with MLD v1 and v2, and alloy switches obviously support all of these various versions. Security functions, I think most of you are pretty familiar with this, I don't need to go through them. The main thing is secure shell. We support versions 1 and 2. ACLs, the layer 2, 3 and 4, including QoS markers, and ICMP and IGMP support as well. So QoS markers means ACLs, we can of course do all our QoS rewrites at any layer that we want to do it, or based on any information on layer 2, 3 and 4. And storm control, again, we have storm control for both layer 2 and layer 3 traffic. So no point having it for one or the other. I say we support it on layer 2 and layer 3. 802.1x is one of my favourite technologies when this came out a few years ago. It was originally designed to run on switch infrastructure, then got hijacked by the wireless guys, and now we're starting to see it out on switches again and being deployed in medium and large network environments. Basically what it does is says that a switch won't enable any traffic to go through it until you have authorized yourself to the network and satisfied me that I know who you are and you're allowed to use the switch. And how it does that with an 802.1x supplicant, which is all available and configurable in most of our modern day clients. And once we turn that on, that allows us to request from the switch to pass our authentication details onto a radius server. Once the radius server can then either authenticate that directly or pass it on to another authentication service such as LDAP. And if the authentication comes back as approved, that port is then open for the device running the 802.1x client to use it and resume normal transmission and communication. So as I said, very nice little nice capability for hardening networks, external attacks. Port security, all this does is locks a MAC address to a port, and MAC addresses can be manually added or detected by the port as first MAC address, and therefore the only MAC address allowed to use that port, and the port is shut down or restricted if another MAC address attempts to use it. So again, handy little layer of security. IP source guard is a bit nicer in that this guy builds up a reference table either manually or automagically of IP and MAC addresses associated and connected to a port, and ensures that all incoming packets are coming from those associated addresses, therefore stopping IP address spoofing, and is a great one to protect against those TCP denial of service attacks. So, and again, all packets not matching are dropped, so no or very little overhead in processing of that. Oh, and again, as I said, those tables can be created manually, but usually by the DHCP snooping, so getting that information out of the DHCP packets coming in on the port. Management functions, went through these in enough detail before. Port mirroring, many to one port mirroring, up to 8 ports can be mirrored to a single port, and obviously the two usages for this is security, where we want to mirror information on what's going in on particular network ports, usually an internet port or similar, and mirror that out to a security device, or if we're trying to debug, for example, a problematic voice phone call, we can actually monitor and mirror all the voice transactions going on across a couple of ports and capture and analyze the data for later analysis. Management functions, said S-Flow, really great technology, traffic accounting protocol, hardware-based agents for wire speed collection. So it collects the entire packet header, so we get layer 2 to 7 application information. So the ability to capture that and process that real time is an amazingly powerful real-time tool for what's going on in our network. And as I say, as distinct from NetFlow, it's scalable because it's built into the hardware. Lots of freeware and free S-Flow analyzing tools out there, and a couple of others that you'll pay for. sflow.org, great place to start your search for S-Flow devices. But some of the stuff this is used for is listed on the screen here, but diagnosing problems, doing an analysis of who's doing what, capacity planning, usage, accounting, billing, and cost allocation is another big one. But just as a LAN monitoring tool, it's absolutely sensational. And keep as much data for as long as you want, and analyze it real time and historical reporting depending on your application and how much hard disk space you have available. As I said, they're capturing that whole packet header, layer 2 to 7 application information. Great way to collect it, and it costs nothing. management functions. We touched on all of them before. Just with ARMON, what I want to mention, SNMP is great for real-time traps and port up, port down, this has happened, that has happened, and getting alerts. What ARMON allows us to do is to grab historical data such as port utilization, CRC errors, and gives us a historical and long-term view of what's going on a port or a network, and then the other groups in there gives us the ability to then sync that within SNMP and have SNMP traps set based on statistics hitting or exceeding certain parameters. So I said ARMON in conjunction with SNMP is a really nice little feature set for trying to debug complex environments. Quality of service, went over the rate limiting before. I don't know if I mentioned 100k increments, but as I say, we ingress and egress per VLAN, per port, or per flow. So not just traffic coming in on a physical port, we can do it on port numbers, and we can do it on flows between two destinations and restrict it between a user and a internet access device, for example. It can be applied in 100k increments. I said policed on ingress, shaped on egress, and all that means is on ingress we drop packets, on egress we drop packets if the bandwidth is exceeded. On egress, shaped means that we have the opportunity to buffer some of that and manage it into a more consistent flow, and that is in fact the only way to do it, policed and shaped, and there's really the only other option if you're going to do ingress and egress is policed, and shaped is obviously a bit more elegant. LLDP, so 802.1.AB is a discovery protocol, and this, for those who are familiar with the Cisco world and CDP, LLDP is CDP open standards with a lot more functionality. And in fact, LLDP MED, or media access, can identify things like VLAN like the name of a device, VLAN it's in, management addresses, and a whole lot more. And with LLDP MED, we have the ability to dynamically configure either a switch port or a device based on what the endpoint is telling us. And usually, the usual way that it's done is that an endpoint device that supports LLDP MED, which is usually a telephone such as the SNOM handsets, that tells the switch port a bunch of information, and the switch port then honors that and configures itself with the VLAN, appropriate VLAN, etc., etc. As I said, 8 hardware priority queues, which is great. That maps straight to our 8 levels of priority of service that are available on most of our prioritization protocols. Scheduling, first in, first out, well, that's no queuing. Strict priority, so that's highest priority first. Can get a bit ugly if you've got a lot of traffic in your high priority queues, because they'll always get serviced first and your low priority may never actually get a look in. So weighted round robin is the way most people goes, and this gives us a guaranteed minimum service level to everybody and a maximum service level to those high priority queues as well. So as I said, weighted round robin is probably the way you want to go if you've got a lot of high priority traffic. If high priority traffic isn't a huge amount of your network, such as, for example, just voice, then strict priority can be very effective there. Classification, as I said, there's lots of different ways we can do classification. So port-based, we can bring it in and classify it. ACL remarking, we can bring it in and classify it based on layer 2, 3, and 4 information. But the actual the priority is stored in our 802.1p or IP precedence or TOS or diffserv, what's DSCP, bits in the packets. So 802.1p, as I said, is at layer 2 and is part of the Ethernet frame, and is in fact only available if we're using tagged frames with 802.1q VLANs. If we haven't got those tagged frames, no 802.1p information, so then we need to prioritize at layer 3 in the IP in the IP part of the packet, so the precedence, toss, or diff serve. And again, as you can see, these things all map out to 0 to 7 or 8 classes in the case of diff serve. There's more bits available in diff serve, but really the recommendations, the standards, default uses is as 8 classes. So you can see how well this maps to our 8 hardware queues. So guys, that was a lot of information, and I've probably gone about as long as I wanted to and a little bit longer. Hopefully you're all still with me. Hopefully it's been of some use. At this point I'll open it up to audio questions, so if you've got any questions that you'd like to ask, if you can use the interface to raise your hand, and I'll unmute you and take the question. Well, that's a good sign. It looks like we've possibly given you too much information there, given that we're not getting any questions back. I'll just give it another minute or so before I shut down the there we go. Good to see not everyone's shy. So, Tony Andrews, I'll just unmute you and you have the floor.
Can you hear me okay?
I can, absolutely.
Okay, all I just want to know is can we get a copy of this, the complete presentation, because as you said, there's a lot in it, and it's just much easier if you can go back over it at some stage of other at your leisure.
Yeah, absolutely. There'll be a recording and a copy of the presentation up on the website at some stage, hopefully today, but certainly before the end of the week.
Okay, thank you.
Okay guys, well that looks like it's about the last of the questions. As we said, the slide deck and the recording will be available on the website at some stage in the very near future, and don't hesitate to contact us or the support group, so everybody knows support@alloy.com.au, and as I said, my email details at the front of the slide deck. Thank you very much for your time, and with that I'll wrap it up.